Thank you, Paul. It's good to see you.
Nice to see you again, Alex.
It's nice. We've got Chris back. We have the Nutty Professor himself of Box Hill Library down here upstairs.
Box Hill?
Down here upstairs at the Box Hill Library, at our super secret, top secret laboratory in the kitchen upstairs, Box Hill Library.
Yeah. So I promise you we won't blow the place up.
We are going to most definitely try not to blow the place up, set fire to it, or leave a mess for the staff of the
especially
branch.
the mess. We've got to clean up. We've got to clean up the mess. I
was confronted by someone from admin the other day, and they said they'd done a very good job of cleaning up after ourselves.
Good.
So
you're learning. We're
going to keep on this good momentum. So today we're going to be making some awesome lava lamps. So for any of you at home who has had a lava lamp before, I've had a lava lamp. Have you had a lava lamp?
Never
had a lava lamp.
Never
had a lava lamp. Sam,
no,
cameraman, have you had a lava lamp? He's had a lava lamp. Chris is the man without the lava lamp. So what do you say? I think we make him his first lava lamp.
Okay,
We're going to make Chris's first lava lamp today.
Good.
And we've got a few very simple ingredients that you'll probably have in the kitchen. If not, you might have to hit up Mum or Dad when they go to the supermarket next. So we've got olive oil. We're going to be using about 2 cups of olive oil. We've got vinegar. We're using about 1 cup of vinegar. Bicarb soda. We're going to use 2 tablespoons of bicarb soda. I've also got some food coloring because I really think that the lava lamp needs to be coloured.
Absolutely.
It's not completely mandatory, but
it gives you a better effect, I think.
It does. It does a
much better effect.
Even though he hasn't had a lava lamp, he's still saying that you need to have colours in your lava lamp.
Well, I've seen them. I've just never owned one.
Okay, whatever. So I've got a delicious, delightful selection of colours here. So we've got blue, red, yellow, and green. Most importantly, green.
Yep.
We'll later on we'll decide what colour we're going to make it. Other than that, we've also I've got this here. So this is like a little effervescent tablet. So it's like a fizzy tablet. So think of like a Barocca or aspirin. Yeah, those sort of thing like that. This one here is like a sports drink one. It's got like magnesium and stuff in it. But you can use this instead of bicarb soda and vinegar. All you would do is you'd pop it in the bottom of your mixture, and then we'd put our vinegar in later on top of it. Sorry, instead of bicarb soda, you still need the vinegar. But for today's experiment, we're just going to be using this stuff. Now, Chris has been doing some research into bicarb soda, vinegars, oils, food colorings, lava, lamps, all of those things. So he's going to tell us a little bit about the chemistry that happens when we add lava to our lamp. That's what we're doing. We're just going to put lava in a lamp, aren't we?
Yeah.
Okay, cool.
Before we go any further, if you want to measure out a cup is about 250 millimeters. So if you haven't got a measuring cup as such, it's got graduations on it, which tells you how much there is. Just get an ordinary teacup. They're about 250 millimeters. Use that.
The ratio we're going to be using of oil to vinegar is about 2 to 1. So even if you don't have something to measure, you can measure out 1 cup of oil, and then you can just fill up 1/2 cup of vinegar, and that'll do. So there's no exact science to it, even though there is a science to it. But in terms of materials, we can make it easy for you guys at home to be able to make it yourself. So I guarantee you, if you put vinegar, bicarb soda, oil, and some color into a cup, you're gonna have a good time.
Yep,
so
absolutely.
More on the scientific side of it.
Yeah, so I thought I'd look at chemistry. What is actually chemistry? Chemistry, I think, is the study of the elements that make up the earth, and it makes up everything that is around us. There was a very famous chemist, Russian chemist. His name was Dmitry, what's his name? Mendeleev. And he got all the elements on the earth and created a thing called the periodic table. And this is what the periodic table...
Not an actual table. It's not an actual table.
It's like that. Can everyone see that?
Here's one I prepared earlier.
Yep, this is from a book. If you want to learn more about it, because this is what chemistry is all about. It is about how elements react with each other. And that's what we're going to do today, is with the bicarb of soda and vinegar. They are two different compounds, and when you mix them together, you get a reaction. And the reaction is bubbles of air coming off it, or carbon dioxide, or whatever there is. So this is a logical breakdown of every substance that is on this planet. We are all made up of some of these minerals. You wouldn't believe it, but we're actually made of iron as well. We have enough iron in us to make probably 200 or 300 mil nails to put it together.
How many people would it take to make one Iron Man?
Ooh, I don't know.
I think it'll take a lot of people to make one Iron Man, but even though we're an Iron Man already and an Iron Woman, we're not an Iron Man man.
No, it'd take too hard.
Okay, gotcha.
So these are all the elements that we're going to be using, that is available to us in this world. There are 118 elements, and out of that, the first 94 elements are natural. The other elements are synthetic. They're usually byproducts of radioactive decay or some radioactive interaction. So just bear that in mind, so that if you want to learn more about chemistry, look up the periodic table on the internet and just look at the elements. The elements are all given names. Like what we're going to use today is we're going to use, before we'll go back one step further. Let's look at what an element is.
An elephant?
Element.
Oh, okay. So it's an elephant.
No, not elephant.
Okay.
Element.
I know what an elephant is.
Oh yeah, okay. So the periodic table is made up of elements, and each element has a letter associated with it. So one of the most common in the world is this. Does anybody know what that stands for?
H2O.
What do you think? It stands for water. Water is made up of H2O. That's one oxygen atom and two hydrogen atoms. So if we had one atom of oxygen, we'd have one hydrogen and another hydrogen there. And that's how water is made. You have a chemical reaction between oxygen and hydrogen. And that gives us water, which is the most abundant substance on this planet. And we are all made up of water too. So we've got plenty of H2O in us. So you're made of
I have lots of H2O. I don't know where I put my drink bottle, but I just had a nice big drink, so I'm definitely full of H2O.
Full H2O.
Delightful.
So this shape here is hydrogen and the O is oxygen. If you want to look at the periodic table, you can get many, many more. It's just the way that chemistry is set up today. And it's quite interesting because we're all part of chemistry, all of us.
It's true.
So with that, adieu. Let's get on with the actual making of the lava lamp and looking at some of the chemical reactions that are going to happen once we start adding the chemicals together.
Ah, perfect. All right, so
over to you.
You are going to clean that off. I am going to make a mess here. So the first thing we're going to get, we might make a little bit of a mess. You know,
okay.
You think about it, lava is messy. You think of a lava, you think of a volcano exploding makes a lot of mess.
Oh, but this is not hot. This is cold, isn't it?
This is room temperature.
Room temperature lava.
Tempered lava is the word I would use. So the first thing we're going to do is, I've got some measuring spoons here. So this guy here, this is a 1 tablespoon spoon.
Not teaspoon,
teaspoon, but it's not a tablespoon, it's a tablespoon for measuring as a tablespoon, but not a tablespoon from the table, and not from the table of the periodic elements.
Oh, that's true.
Yes. So this is a 1 tablespoon, and this is the only tablespoon we're going to need today.
Good.
The other stuff is going to be measured out in cups. But what we're going to do is, the first thing I'm going to do is I'm going to get some bicarb soda. So I got this guy here, this bicarb soda, just from Woolworths, cheap. Mum or Dad probably has it in the cupboard. It can be used for cleaning, baking,
cooking,
lots of things. Lots of things. I use it. Do you know what I use it for?
What?
I get water bottles and I have a tendency to leave water in them, and they get funky. They smell weird, and they come all funky, kind of like,
that's right.
You know, our 1970s lava lamps, lots of funk. I put some bicarb soda in there, leave it overnight. fresh as a daisy in the morning.
You can do the same thing to refresh, and I've been told to freshen up fridges. If there's a stale smell in the fridge,
yeah, makes sense.
You can get a cap full of it and just leave it in overnight, and it absorbs all the bad smells.
Well, I might have to do that because I'm moving house soon, so
yeah?
I have to clean out the fridge and make sure everything's nice. So I'm going to do 2 tablespoons of bicarb soda. I'm going to pop that into our little jar. So we've got our jar here. Don't forget that. Very, very important.
2. We need 2.
2. I'm the Count from Sesame Street now.
Okay.
So 2 of them, bad boy. This guy is gone. He's done. I'm going to put him over there on the side. We're not going to need any more of this bicarb soda for today.
I'll take it.
You can have it. Take it home. You're going to have it for dinner. We're just going to give it this little shake. Make sure it's nice and level because we're doing science here. This is an official science beaker. It has measures on it.
Okay.
So there's that. So the next thing we're going to do is we're going to get some olive oil, vegetable oil,
cooking oil.
You could use motor oil. It's kind of clear. You can see through it. Any oil that is oily.
It's too heavy. This is light oil.
This is true, unless you use a very light oil, like a 5W40 or a 5W30.
Yeah,
you know?
Could do something like that.
So I've got olive oil here, fresh out of the Box Hill staff room kitchen. I've been stealing ingredients from the Box Hill staff room kitchen for the last couple of months for making videos, not for eating at home. So they're not going to need that. We've got more important lava and lamps to make.
Okay.
I've measured out 2 cups of olive oil. So in this cup is 2 cups. So even though it's 1 cup, it's actually 2 cups. So the capacity of this cup is equivalent to 2 cups, even though it's 1 cup. Does that make sense?
You're confusing.
I feel like I'm speaking a little bit riddly today. I'm
having a bit of fun with it. I think you are.
My spoons and periodic tables and elephants. So what we're going to do is we're going to grab our oil, our nice fine powder solution, and we're going to pour this guy in.
Very slowly.
And we're going to try not to dribble it down too much. Okay, there we go. I found a rhythm.
Pour it in very slowly so you don't mix it too much with the bicarb. So point it very slowly.
Exactly. We don't want to disturb the bicarb at the bottom. The bicarb needs to stay at the bottom. We don't want it to mix together. So if you have a look there, there's a good layer of it in the bottom. So if you can see that, we've got bicarb, we've got oil, we've got air, we've got jar, we've got lava, we've got Chris, we've got Sam, the cameraman, and we're going to make.
I can imagine also you don't want too much bubbles in it as well. We don't
want too much, but we want some much.
Do we? Oh, okay.
Well, that's where this is in when we pour it.
Yeah.
Gotcha.
Yeah.
No, you're right. Yeah, I thought you meant at the end when we want all the bubbles of the lava.
No, I wasn't preempting anything. No.
Stuff. Perfect. All right, I'm going to give this to you, Chris.
How much do we want?
So we are going to pour half of this cup, which is 1 cup. So as I said before, we're doing a ratio of 2 to 1. So for every 2 cups of oil, we use 1 cup of vinegar.
There you are.
So now we have our vinegar. Does it smell like vinegar? I'm not lying.
Cool. Yeah, it smells like vinegar.
I smelled it before. What color do we want to make it?
We'll go for green.
We'll go for green.
I know that you like green.
Green in the green cup. I like it. Let's do it.
How much shall we put in?
So we're going to put in 2 drops.
2 drops?
2 drops.
1, 2.
And we're going to use any object in the nearby vicinity to give it a stir, which happens to be a measuring spoon. So if you've got a paddle pop stick, icy pole stick, walking stick,
do you think that's
spoon,
enough? What do you make sure you go more?
It's in a green cup, so.
Oh, that's true.
What do you guys reckon? Try not to pour it all over everything. I think we need some more. It still looks like some pretty weak cordial in there. So
yeah, I think
we'll go 1 more drop.
You want 1 more drop?
1 more drop then. Okay, fine. You've won. 1 more drop. We'll see how we go.
Make sure you don't get too much of the stuff over you. It goes a long way.
I'm going to take my food colouring home. Back over to my pile of tricks. I've got my box of tricks on the side.
That looks a bit better.
So now we have our green solution. I'm going to give Sam, the cameraman, a nice look there. You can see in there, it's nice and green. I can see everyone on Zoom having a nice look down into that one there. I can see some blue. Oh, let's hold that blue one up. That looks awesome.
Yeah, very really nice royal blue.
Yeah, very deep blue.
Oh, pink one. Pinky red. That's nice. What else is anybody else got any other colours?
Oh, we got some there.
Oh, well.
Very nice. I see that one there. Cool. All right. So,
moment of truth.
This is the moment of truth. So the next part is the drop. We're gonna be doing our lavering of the lamp, as I like to call it.
Okay.
Excited?
Yeah, I'm excited. I'm interested to see what happens because I don't know.
See, the thing is about this cup of vinegar is it's that nice. Do you know that Cotty's green cooler cordial?
Oh, yes.
It looks exactly like that. And I look at it and I'm like, I just want to drink it. I'm so thirsty.
No.
Delicious, but it's got that horrible vinegar smell to it. I mean, delicious vinegar smell to it.
Yeah.
Okay, so we're ready to go.
Okay.
Seeing as you have not had a lava lamp before, I'm going to give you the honours of lavering this lamp.
So how do I pour it in?
Pour it in, and if it doesn't bubble straight away, I'll give it a little stir. So we can take our spoon. So it doesn't matter now whether or not.
Do I pour it all in at once, or do I just let it drip down the side?
Pour it all in at once, because we want it to disturb a little bit.
Oh.
So now, give it a little bit of a. So we're going to start to see.
Oh, look at that. That's the reaction that's happening. Can you see all the bubbles coming up?
It's going to slowly start bubbling away, and we're going to get bubbles of green deliciousness in our gold solution starting to come up. So it's pretty impressive. And the reason why that's happening is we've got some nice acids there in our vinegar reacting with our base in our delicious solution. It is getting a little bit feisty, I'd probably say.
Oh, I can see that, yeah. It's really starting to go. Look at that.
I might even go even a little bit closer, as long as our camera can keep up with that. I think we've got some very
We've
nice,
got some nice ones there.
Nice
I can see it.
There. We've got some nice focusing going on by Sam, the cameraman. He's managing to track my shaky if quite well. We can see some other people are really starting to get some pretty cool bubbles going on. So if yours hasn't started bubbling yet, you can give it a little bit of a stir,
but not too much.
Just want to give it a little bit of a poke. You just want to break the seal on the top of the bicarb soda and just get that camel krill reaction started.
And once the reaction starts, it just continues on from there.
So here we go. For you,
oh my goodness,
my good sir, your first lava lamp. I'm sorry that there's no actual lamp, but there is definitely lava. And by lava, I mean oil and bicarb and vinegar.
That looks incredible.
And green. It's actually quite good, isn't it?
Isn't it?
It's impressive. So if you've got, a little torch or something like that, you could even shine it in behind it. We can make this into our very own lamp.
Look at that. I like the green. That's a nice colour.
See, I told you, don't want to use too much.
Yeah.
That's the secret. It's actually working quite well with the colour of the oil as well. So
yes, this
will bubble on for a little while, and you'll get to enjoy the splendours of your coloured lava lamp for a good minute or so. And then once it's done, what you can do is you can pour it out and you can make another one in a different colour.
Yes, that sounds like a lot of good fun.
So I am pretty impressed with our lava lamp experiment. This is not my first time lavering of the lamp.
Isn't it?
No, it's not. So if you have a look on our YouTube channel, we do have another video of it. I did one at home last year during lockdown, and this is a better lava lamp. This is Mark II. This is my gift to you.
The other one that you did, has that got the proportions in it as well?
It does have the proportions, but we will have this video saved as well. And have it ready for watching later, because this has been a triumphant success of live lava awesomeness.
So remember, chemistry is around everywhere that we are. You know how we breathe in oxygen? We're breathing in oxygen and we're giving out carbon dioxide. That's a chemical reaction that's happening. So chemistry is with us everywhere.
Don't drink it.
So if you want to find more about chemistry, look up on the internet and start at the periodic table, and that will give you a good idea of how the elements are put together and what the world is made of.
Absolutely.
Because they're all the compounds that make up the Earth.
Yep,
and make up
absolutely.
us as well.
It's exactly true. And also, remember, do not drink this solution because it does not taste good.
No, I wouldn't try it.
Yep. Did you see what I did before?
Yes, I did.
Okay, good.
I think you were very brave to do
It was
that.
very brave or very stupid. I can still taste it. I definitely don't recommend it. My mouth is oily. My mouth is olivey, green, and bicarby, sodary, and vinegary.
Good.
And I'm probably going to need to have a nice glass of water to
wash it
that
down
out of my system. But maybe what we'll do now is say goodbye to our pals on Facebook and thank them for joining us. And we'll take a look at some of the awesome ones that our Zoom participants have created. So catch you later, Facebook guys. We'll see you soon.
And we'll probably see you next week. Bye.
All right, Zoom folks.
That looks absolutely amazing.
I know.
Mesmerising. Got a question about the aspirin. When would you apply the aspirin?
So what we can do is I might just quickly pour this out and then we can do a really, really quick demo using this guy here. So I haven't tried this method before, but we'll do it now. Essentially, it's the same sort of thing. So if you were to put this in just to water, it would bubble and fizz and carry on and stuff like that. It's essentially the same thing, but we're putting with the oil and we're putting some color in there with that color of the water.
But you don't put in the bicarb of soda. You just put in the tablet and then put the oil on it, and then you put the vinegar on top. Oh, the other thing you should do is also it should be an open container. You have to let the carbon dioxide out, otherwise you might blow up the bottle.
Exactly.
So be wary of that. You need to be able to have, like this one, it's an open-ended jar. There's nothing in the top of it.
So the scientific beaker.
Scientific beaker.
Scientific beaker.
Okay.
Definitely not a coffee cup from the cupboard that I stole off my girlfriend.
No, definitely not.
Sorry for stealing your coffee cup. It is a keep cup, so we can keep this cup.
Was that Katie?
It was.
No.
She won't be impressed. So we've got our tablet. So that's our little tablet guy. And I'm going to pop him some. So you can prepare the color solution. I'm going to give you
red,
blue, because
blue.
This is an orange tablet.
Oh, okay.
So I didn't think about that beforehand. So I'm just going to free pour this one here. So we're going to we're just going to live a little bit.
Got to live on the edge.
Live on the edge.
Give us a
Look
spoon.
how much. Look how much. What do you need?
Spoon.
There's one here.
Oh, sorry.
There you go. It's a bit oily.
Yeah, I know. Bit slippery.
So, yeah, this one here is an orange tablet. It's a Zeus or something like that.
Okay.
Effervescent tablet, but we're going to give it a go.
Pour it in.
Pour it in. See what happens. It might work. It might not work.
How's that? Do you want to put the spoon?
It's doing something.
Oh, it's starting to.
So we can see, that it's starting to do a bit in there. It's not quite as active as our bicarb soda, but this will last a lot longer. So think of it kind of like a bath bomb. In fact, you could probably use a bath bomb for this.
Oh yes,
you could use a bath bomb.
What you did last week.
I have a bath bomb. Here's one I prepared earlier.
Look at it now. Look how far it's going.
Crazy. So we're gonna hold that up for our pals.
Have a look at that. That's a pretty good reaction.
Yeah, that's really good, and it smells like orange.
Oh, it does too.
Yeah, so this is an orange sports drink effervescent tablet. So this one's going absolutely crazy.
Looks great.
Fantastic. You could also use a bath bomb. So this is a tiny little bath bomb that I made last week in our session. I still have it ready to go to have a bath sometime in the near future. Haven't had a bath since last week, so
What's that? What the smell is around here? Oh God!
Just
when was the last time you had
have a whiff of that? You can enjoy the lavender and the fresh deliciousness of that. But yeah, hopefully that answers your question in regards to using one of the effervescent tablets.
Or aspirin.
Aspirin's an effervescent tablet.
Is
effervescent is fizzy.
Yeah, fizzy. Okay.
Tablet is fizzy. Effervescent tablet is a fizzy tablet.
Okay.
That's what we've got there. So hopefully that sort of gives you an idea of what to do if you wanted to use an effervescent tablet instead of bicarb soda. So you could raid the cupboard, go grab some Baroccas or some vitamin D tablets, sports drink tablets, aspirins. You might need a couple of aspirins or Disprins or any of the, whatever your favourite flavour of aspirin is. Yeah, cool. Any other questions?
Yes.
No, that's all for questions. Do we have any final questions? I can see, little bloke with his hand up. Is that with Catherine? Do you have a question?
What did you want to do? Will it actually blow up?
Will it actually blow up? Well,
No.
if you close a bottle, if we were to dump bicarb soda in this, close the bottle, shake it up, it might not.
It'll pop.
It'll pop. It won't blow up. It'll probably pop the lid off before anything, and it might make a big mess. So I'd probably avoid doing that one there because it'd end up all over the walls and all the floor and the oven and the kitchen and everywhere. And Mum probably won't be too happy with you about doing that one there.
No.
I know that the branch staff here at Box Hill Library would not be happy if I did it. Otherwise, I am tempted to do it in here, but probably not the best idea. Plus, I need this vinegar. I'm thinking about going home and making a salad.
Are you?
You know, frying up some chicken with my oil, some bicarb soda over the top.
What for?
I'm just joking. But yeah, don't try that at home.
No.
Bad idea. Maybe we can do a session of blowing up bottles in the park. We'll ask Paul if we're allowed to do that. It might be a bit of fun. It's probably not a great one. Not educational enough, I think. With blowing up bottles. We've got bottle rockets for that.
Yeah, we got water rockets for that one.
Exactly.
Yeah. So that's something you can look out for later on in summer. We'll do water rockets.
Yeah.
You can come down and join us and you can design your own rocket and we'll blast them off. They go about 30, 40 metres into the air.
Exactly.
So
you don't need any oil, you don't need any vinegar, you just need water and
a bit of pressure.
Yep. And a bit of pressure.
Yeah.
Cool.
I've got another question from Taj. He wants to know what will happen once the fizzing stops.
Once the fizzing stops, the fizzing will stop and you can pour it down the drain or...
I wouldn't use the oil again.
I wouldn't use the oil for anything.
The reaction will slow down.
It'll slow down. So I can see there that yours is, I think it's stopped fizzing and you've just end up with a bit of a murky
frothy
green,
sort of thing.
Frothy bottle of frothy goodness. So yeah, you can dispose this. These are all organic, homegrown from my garden at home where I grew my vinegar and the bicarb soda. So you can pour them all down the drain without too much issues, with a bit of fizzing, but other than that, not really.
It's not dangerous.
Not dangerous. So you don't have any harsh chemicals here.
No.
And doesn't matter if you get it on your skin, it's not going to do anything unless you've got a cut on your finger and it actually starts to sting. Which that did.
Did it?
Yes.
Oh, that's probably the vinegar. Yeah, that'll make it.
Didn't think about that. Had a little cut on my finger. But anyway.
Okay.
Cool.
Any more questions?
I have a question. You know, with actual lava lamp, which is a lamp with all the liquids
with a lava
through.
Yeah.
Does it keep going? Is that heat coming through the lamp?
So what happens is the solution inside heats up, and as we all know, heat rises. The hot lava in the bottom, which is not actually lava, just if you didn't know, that rises up, and as it rises up, it comes to the top and it starts to cool down. When it cools down, it goes to the bottom and it sort of creates a bit of a waterfall-y effect.
Yeah.
Can't remember the word for it is, but it just keeps rotating and going round and round and round. Essentially, you could do the same thing with this. If you were to heat this up, and if it was tall and sort of skinny, it would just keep going. We're using the bicarb soda and the vinegar at the bottom to create a chemical reaction, but all that is doing is just exciting and stirring up the water and the oil in the top. So it's making bubbles and things sort of happen. So, yeah,
that's it. Very simple.
It's
very effective.
An actual lava lamp is actually quite simple. All it is water and oil and color and lamp.
And heat.
So the lamp is what keeps it hot. So the bulb at the bottom is quite hot. If you have an LED lava lamp, it probably wouldn't work very well because it wouldn't be very hot.
There's not too much heat involved.
Exactly. So, yeah.
Okay.
So if you had a lava lamp bath, like you were talking about, Alex, before with your...
Could have a lava lamp bath. So if you were to have a cold bath tub full of cold lava lamp juice, And if you were to heat the bottom of it, and if it was a tall bath, i.e. maybe a shower cubicle bath.
Wow, that's a lot.
It's a lot of bath. I've seen it done before. It reminds me of that. There's an Andy Griffiths book where he fills up the shower cubicle with silicone all around the edges, and he fills it up, and then he breaks the tap, and he gets stuck in the shower and has to go through the roof. Very, very funny. If you were to do something similar to that, somehow to create a heat source at the bottom, probably don't want to light a fire underneath your shower at home. But theoretically, if we were to have a big light or some sort of heat source underneath our shower, it would stir it up and you'd get bubbles in our shower bath. They'd rise to the top, and as it gets to the top, it would cool down, and then they would fall down again, and the hot ones would start rising. It would just keep doing it over and over again, and that's why we get our wibbly wobbly.
And that's why it changes shape as it rises and
thing
falls.
Going on. Exactly. Yeah. Yes. Yeah. So I don't think we should do that one there. I don't think a lava lamp bath shower with a fire underneath it is viable, but in theory, it would work.
Oh, thank you guys. That was absolutely amazing. Wonderful seeing that. I love seeing all the bubbles and the colours.
And lava.
I love seeing some of the examples we saw at home with all the different colours.
Yeah.
Yep.
For sharing those.
It makes a difference.
We don't have the time to do all the colours of the rainbow, even though we have all the options under the 4-colour arrangement of Queen's food colouring industry. But it is good to see everyone else with their awesome, funky coloured lava lampage.
Absolutely.
Yes.
Enjoy yourselves. Enjoy experimenting.
And remember, do not drink it. It's not good. It's not tasty. Not tasty at all. I can see Sam, the cameraman's eyeing it off. He can smell the orange, but I'm not going to let him. So
no, definitely not.
No. So cool.
Okay.
Well, thanks, guys, and thank you everyone at home for joining us.
Bye.
Absolutely.
As much as I did, and we'll hope to see you at the next online session, maybe next week, perhaps next Tuesday or Wednesday. But
exactly.
on the website, we'll post something up there about that.
Stay tuned for more. We will be back soon, and hopefully back soon in site, on branch, on premise, doing our normal stuff. But who knows? We will see. If not, we'll see you on Zoom and/or Facebook.
No, next weekend. Next week we've got
YouTube.
Next week we're still in lockdown.
We are still in lockdown, so we definitely won't be on site.
No.
Awesome. Cool.
Okay.
Sounds like a plan. We'll see you then, guys. We'll see you soon, Paul, as well.
Bye.
See you guys.
Everyone.
Take care.
Well.